Hello everyone, I am Veda Shanubogue from Institute of Technology. I am currently pursuing my Electronics and Communication degree and currently I am studying in 4th year. So this is my internship project which was conducted by Emertxe Information Technology, and the topic of the project is IoT based home automation system. First of all, I would like to thank Emertxe for providing me this opportunity, and special thanks to our mentor Jayalakshmi and Danyal. I thank my teammates Sri Harsha, Srinit, and Suhas for helping us and help build the project. So these are the contents which I am going to roll out in the presentation. In the lectures, we learned first about C programming, the basics. From basics, we started, and then we moved on to what we need for a project. Then Internet of Things basics, embedded systems, and then microcontroller. So in the project, I'll show the overview of our project, the objectives, design elements, simulation, and then I'll conclude. So in the starting of the internship, we started with C programming. So it is a very general purpose language and is used very effectively in various technical domains. And this is how the simplest code of C looks like. It consists of a file header, which means what is there in the C program. Then some preprocessor directives, which help the C code to initiate the libraries which are used. Then the main program starts, and it starts with main method. Then inside the main method, we write all the functions, all the comments, all the statements we want to execute, and then finally we terminate that program using return. So topics which we learned in C were the basics like data types, there are like 4 or 5 types. For examples of data types are integers, characters, strings, float, double. So these are the data types which can be used. Data types are usually used to define what variable or what identifiers we use. We learned about various conditionals and loops. So basically loops are the most important part of any coding or any programming. Loops, there are basically 4 or 5 types of loops, which consist of for loop, while loop, if loop. Then we learned about operators, arrays and pointers. Arrays is a very important topic which deals with memories and basically if you want to pass an array, we can pass an array of matrix, we can pass an array of a long sentence, etc. We learned about function, we learned about preprocessor directives, what are the different storage classes, etc. So these were the topics which we learned in C. Then we moved on to Internet of Things. Internet of Things is basically a collective network of connected devices. So collective network means the collection of various types of computers or mobiles of connected devices which are connected via internet. So technology that facilitates communication between devices over the internet is basically Internet of Things. So in this block diagram, we can see that house is connected to our mobile via Internet of Things, and we can control our home appliances using. If we are not at the home, still we can control the systems which are present in our house. So the mechanism behind all these things is the Internet of Things. So Internet of IoT system works through a real-time collection and exchange of data. Moving on, there are various applications in various domains like automobile domain. We can smart cars is a very best example for application of IoT in automobile. So as you all know, internet car is a new trend which is trending in the technological world. Then for business purposes, for manufacturing purposes, and to add to these applications, we can also include security purposes, which can be used for via IoT. Like for example, if we fit a camera in our home and connect that camera through our phone, we can check our home if we are not at currently staying. We can, if we are going outside, we can check our security at our home through our phone app only. We don't need to come to our home, then connect that camera to our system, then see the recording now. Via Internet of Things, we can uh, see the recording live from other places also. Then comes embedded systems. Embedded systems is a combination of computer hardware and software design for a specific function. So embedded system is basically a system, a full system on a chip. So it is a combination of various computer hardware and software. So in this block diagram, as you can see, there is a basic sensor which requires an analog to digital converter. So sensor usually senses and produces its output using the as an analog signal. So this analog signal we have to convert to digital signal for further operations, and for that we need an analog to digital converter, or it is abbreviated as ADC. Then the function which we receive as a binary sequence or a digital sequence then is processed via different kinds of processor. So this processor block can be our Mega or ARM processor, any processor we can use to control the system or make that binary sequence like we can use that processor to convert that digital signal which we get to whatever we want to do. It basically has a memory unit, and then the digital sequence we need to convert it into analog sequence for the actuator to initiate. So this is our basic flow of embedded system work. So they are the advantages of embedded system is that they are very low cost, low power consuming small computers. So this is very important. For doing a great operation, we are using very minimum amount of power. So in the trend, basically, it is the main point that using the low power, how we can create or build a system. So these are the applications and examples of embedded systems. As you can see, robotics uses. We can see small robot doing so many different things via in a single tap. So that is all the systems are embedded into a single chip. So that's an application. Then in medical field also we can see small sensors using X-ray sensor or many different sensors are used which are very much applicable in medical field. For example, implanted heart monitors are there. They are very minute chip, but they perform such a big function, which is using embedded systems. Then microcontrollers. So what is microcontroller? Microcontroller is basically a computer on a small board. So it has its own CPU, it has its own memory unit, and input output ports. Everything it has in one chip itself. So what are the things which a typical microcontroller consists is? One is ADC or DAC block. ADC and DAC block. ADC means analog to digital converter, and DAC means digital to analog converter. So this is the main block, starting and end point of microcontroller. Then we have timers and counters. So timers is basically used to calculate how much delay or how much time they require for to keep track of time, and counters are also used for that. Then we have processor and memory units, input output ports. We have okay, so what is the basic difference between microprocessor and microcontroller? The very basic difference is microprocessor does not have a CPU built inside its chip. We have to connect different CPU, outdoor CPU unit should be there. And in microcontroller, there is an inbuilt CPU unit. So there is no need to connect any other CPU for working. Then I'll come to the overview of our project. So basically this was the different things which we learned during the internship, which was first was C programming, then Internet of Things. We were introduced to embedded systems, and we learned the architecture and the basic building blocks of microcontroller. Coming to project, this project provides an IoT-based home automation solution using Arduino Uno board, and this is done in PixSim Lab Simulator. So the title of the project is Internet of Things based home automation solution, and we have used Arduino Uno board, not in a hardware but in Pixel simulator. We have used Blink IoT mobile application to control the devices, and there are like three parts in our project. First is controlling the garden lights. The second is temperature sensor at our home, and the third is serial tank calculator, serial tank water controller. I'll go through each of the part in the coming slides. So the objectives of our program project was, first was to connect the home appliances to the Pixel simulator and integrate it with Blink IoT app using Blink Cloud. So as it is clear, we connected all different home appliances to our simulator and then used that Blink IoT app to integrate it. Various such appliances were controlling lights, temperature at home, along with the level of water tank. We this How did we control and integrate through Blink IoT app is, whenever the peak is found, we in our mobile app Blink IoT app we get a notification, and through that notification we can be alert and do the basic function which we need to do to control the temperature or control the lights. So why did we choose home automation as our project is, generally people always don't stay at home, and this brings the problem of home appliances not being monitored. For example, in the morning we started our water tank to fill, and we went out for work or for college, and we forgot to switch off that serial tank. So that will be a waste of water, that will be a waste of energy, where everything will be wasted and nobody is there to control it. So that's a very basic example, but our project is useful for controlling that serial tank and monitoring that serial tank, how much water is filled, how much water should be filled, and when it needs to be stopped. And this can be done remotely when we are not at home also. So the solution of this problem comes out of home automation. Home automation enables people to control most of the devices remotely. So as I said, the volume of water present in water tank and garden lights, temperature of home, everything can be controlled even if we are not at home. So this is a very big reason why we chose home automation. Arduino. As I said earlier in our project, we have used Arduino as our basic microcontroller. So why did we choose Arduino? What Arduino Uno we chose? I'll go through it. Uno is a microcontroller board based on Atmega 328P. So it has 14 digital input-output pins, 6 analog input-output pins, and a 16 megahertz ceramic resonator, a USB connection, a power jack, and an IC/PC header and reset button. So these are all the qualities of Arduino Uno board. It can be programmed using different IDE, and Arduino IDE is used in this project. It can also build using C++ languages. So Arduino IDE supports C and C++ languages. PixelLab is a simulator we used for checking the output and checking the various levels. PixelLab is an very open source real-time emulator of development boards with integrated debugger. This is the debugger we used, MPLabX AVR GDB debugger. So it has inbuilt and it's open source, so we don't have to worry about simulating and paying money for that. It supports some Pixel microcontrollers and some SIM AVR microcontrollers. It has integration with Arduino IDE for programming the board's microcontrollers. So it is basically we can expect a hardware, but in computer. Like we don't need a hardware. Everything which is shown in that hardware Arduino, we can do it using PixelLab microcontrollers. So Blink IoT is used for integrating, as I told, the PixelLab simulator. So why did we choose Blink IoT was, it is very easy to operate and user friendly. So how to create is, what we did is we created a new template, and in that we added every home appliances to that, and data stream can be added, various types of blocks can be added as it is shown in the figure. Okay, so I'll now go through the various sensors and various components that we have used in our project. So in the first part, that is the garden lights part, garden light is in our gardens, if there are lights present, and if we turn on in the morning and then go outside for a vacation and we forgot to turn off, so it can be controlled using LDR sensors. So that is the part where we have used this sensor. So LDR is light dependent resistor and is a light detecting sensor that detects the lights that falls upon it. The photoresistor is a light controlled variable resistor. The resistance of a photoresistor decreases with increasing incident light intensity. So what happens is when the light falls on the surface, the resistance of a photoresistor decreases. So the LED lights are connected to the LDR via the ADC. So this LDR is connected to LED or the garden lights via analog to digital converter. The analog to digital converter converts the analog input given by the LDR into its equivalent digital form, which is then converted later by certain formula from 0 to 255 as an upper bound. Based on that, we glow the LED. So what happens is, if the sun rays are very high, like in the daytime, the light will be low and the resistance will be high. So if the resistance is high, the light will go in light will be off basically. And in the night time when the light is low, and in the night time the light falling on the LDR is low, the resistance will decrease and the LED will grow in its maximum brightness. So this is the basic block diagram. So Arduino Uno is connected through LDR sensor and Arduino lights connected via Arduino. Arduino Uno has an analog to digital converter block. So the properties of LDR sensor is applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum. So LDR detects the light and the garden light is turned off. So as the light rays falling on the LDR sensor increases, the resistance also increases, which turns the LED off. So whereas at night the outdoor light is very low, so the LDR detects the light and the light is turned on. So as I said, in the night time the light falling on the LDR is very low, resistance is very low, and the LED will glow. The second part of our project is temperature sensor. So temperature sensor of home, which is very important. If any fire takes place, fire took in our home due to various reasons such as geyser or iron. So we can check the temperature, and if the temperature goes very high than expected, we can turn on the cooler or we can give some other mechanism. So here LM35 is the temperature sensor we have used. So the temperature is recorded using LM35 sensor, which reads analog value. So this has only 3 pins. One is the pin we give to microcontroller, one is the VCC, and one is ground. The value is converted into binary value, and later actual temperature is calculated using the obtained value of the voltage. So this sensor gives the output as analog voltage. So that voltage is converted into binary value, and based on that binary value, the temperature of the given room is decided. The sensor does not require any external calibration or trimming to provide accuracies. And this sensor provides an accuracy of 0.5 degrees Celsius at room temperature and plus 1 degree Celsius over the range of -50 to plus 55 degree temperature range. So the output scale factor of LM35 is 10 millivolts per degree Celsius. For instance, it provides an output voltage of 250 millivolts at 25 degrees Celsius. So this is how the microcontroller will get to know that the temperature is 25 degrees Celsius. So when 250 millivolts is passed to the microcontroller, it will sense that and convert it into a digital value, and again convert it and notify the blink app that the room temperature is 25 degrees. How do we temperature control system? How did we build it in our home in our project? Is this is our main Arduino Uno board to which temperature system is connected. So what this temperature system will do is This will transmit the temperature voltage to the Arduino. This Arduino will sense the temperature and send it to our Blink IoT app. In Blink IoT app, we can see the temperature via notification. So if the temperature is very high, the display temperature in our app, so we'll give the we'll press the button of heat cooler control. As soon as we click cooler, it will get transmitted to Arduino, and then it will be executed via temperature system. So that this is how the exact flow of temperature control system works. So CLCD is the display for our home, which will send the notification and temperature. Notification of the temperature will be sent as notification to the CLCD. Okay, so coming to the third part of the our project, the third part of the project is serial tank monitor system, water tank system. So water tank inlet and outlet valve control. So to in a simple words, it's like there is a water tank and water tank is filling, and we can control the level of water tank via our app. So we can start the like we can start the flow of water, and we can control the frequency of water also. I'm sorry for the disturbance in the background. Okay, so how is the exact flow of the system is? The water tank is connected through Arduino, no? And there is a sensor of water level sensor. So volume of the water is continuously being displayed, sent to the Arduino, and this is sent to our app using notification. And when the maximum level of water is reached, we'll press the button of stopping the system, and then this will be transmitted via Arduino to the water tank, and it will be executed. Same, the volume of water will be displayed in our CLCD via notification. So control of volume of water in the water tank by controlling the inlet and outlet valve by sending commands through serial communication, and display the volume of water in the tank on the CLCD and also in the Blink IoT app. So the tank refills itself when the outflow exceeds the threshold of minimum value of 2000 liters, and it stops filling when the tank is full at 3000 liters, and gives notification to the Blink IoT app. So as I said, if the water level is decreasing, as soon as it reaches 2000 liters, it will start we can start using Blink IoT app, and it will fill the water up till the threshold of 3000 liters. As soon as 3000 liters of water is reached, we'll get a notification that the water level has reached, and this is how we get to know that our tank is full. So this is the third part which we have executed in our project. So this is basically the image of the simulation. So as in the display, it is shown volume is equal to 3000 liter, and the inlet of the water is off. Temperature is 27.4 degrees Celsius, and here the LDR is connected. So for the conclusion, I'll tell in summary of this project, we provide a solution of monitoring and controlling home appliances and certain devices remotely. The three parts which we have controlled and monitored were garden lights, temperature, and serial time. Using Blink IoT, weekend application, and PixSim Lab simulator, home automation project is simulated where LED, temperature system, and serial tank resembles lighter, heater, cooler, and water tank in real time. So, as I said, the home automation components which we used were LEDs, which was light, temperature system, which was heater and cooler, and serial tank, which resembles water tank. Blink IoT application allows user to control these devices according to user's wish, thus accomplishing home automation. So Blink IoT, as we all know, which is in our mobile app, and we can control all these home components which are there at our home via our mobile click. So that is how we have achieved our home automation. So thank you, and at the end I would like to show our simulation, and based on how we have done. The simulation video has been done by my colleague and my partner Srinit. I'll let you I'll let go of presentation right now, and I'll show you how the simulation is done.
Okay, this is a code which we have used in our project. This part is for IoT app, IoT Blink IoT authentication, which helps us in monitoring our code from mobile. Uh, the first part in our code is for uh, temperature system that is given here, and when the temperature is greater than 35 degrees Celsius, that is here, the heater should turn off because that is not a normal for a room temperature. And when temperature is less than 28 degrees Celsius, that is the actual room temperature that is shown here. The cooler should turn off here. That is the second part of our project, temperature system. And third last part of our project is about cereal tank. When the tank volume is less than 1500 degrees Celsius, that is what we have taken in our project. And when less than 1000 degrees Celsius, the inlet should automatically turn on. And a notification should pop up saying that inlet valve is the water level is less than 1500 liter, so inlet valve is turning on. The maximum level is here 3000 degrees Celsius, 3000 liters, and when tank reaches 3000 liter, the inlet valve should turn off. And whenever we turn on the outlet valve, the water should flow in opposite direction. Okay, first part of our project is about garden lighting. This is the LDR. When resistance of LDR is very high, garden light should turn on. That means it is night time and LEDs will glow. Uh, Next, when we decrease the resistance of LDR, the light should slowly turn off. As we can see, now the light is turning off and it is completely off now. This indicates that it is daytime and LEDs will turn off. Next part of our project is about temperature in a home, and as we can see, this is our Blink IoT app which we are monitoring with our mobile. And when I turn on heater, the temperature should go till 35 degrees Celsius. When temperature is greater than 35 degrees Celsius, the heater too should turn off, and we should get a notification in our mobile screen saying that the temperature is greater than 35 degrees Celsius, and heater will turn off automatically. Now if I turn on the heater, yeah, as we can see, the temperature is increasing slowly, and when temperature is greater than 35, it should turn off. Yeah, now we can see that the temperature has turned off, uh, and a notification is appeared here saying temperature is greater than 35 degrees Celsius, and heater is turning off. Now if I talk about cooler, when I press this cooler button, temperature should fan is rotating now, as we can see, and temperature is decreasing. The cutoff for temperature is 27.9 degree Celsius. At that time, at that point of uh, at that temperature, the cooler should turn off and notification should appear here. As we can see, notification also appeared here, saying that the cooler has turned off because it is a normal room temperature. This is about our temperature sensor project. That is the second part of our project. The last part of our project is uh, about a cereal tank, and in the cereal tank, the maximum volume of water which it can store is 3000 liters. And now, initially, I have completely filled the tank. That means it is completely filled, and 3000 liters are filled here. Inlet is currently off as it is completely filled. Whenever I uh, turn on this outlet, the water should flow in opposite direction. That means it should empty the tank. If I turn on this, uh, yeah, as we can see, the water is decreasing. The cutoff what we have taken in this is 1500 actually. That is what we have made changes in our code. Uh, uh, and whenever it reaches below 1500, yeah, it reaches below 1500, the inlet should turn on. As we can see, the inlet is turned on now, and a notification has popped up here saying that water level is less than 1500 and inlet has turned on. Uh, Now I cannot turn off the inlet now because it has already reached the cutoff. Now if I turn off the outlet, it should increase again. As you can see, the water is increasing here, and notification will pop up here saying that the water is completely filled. uh, Now if you see here, yeah, now notification has popped up here saying that enabled water level is 3000 liter water inflow disabled. Inflow is now disabled. Inflow will disable only when the water is completely filled or it is greater than cutoff, but below cutoff we cannot turn off the inlet. And now again, if we can turn on the outlet, and we can see that water is flowing in other direction. And I can turn off the outlet now. Yeah, as we can see, inlet has not turned on now because the cutoff has not reached yet, and water level is, and we can see here water level is 2250. And that is about our project. Thank you.
So, thank you, Srinit, for explaining the simulation part of our project. I therefore conclude by saying thank you to everyone in my group, and thank you, Jayalakshmi ma'am, for mentoring us. Thank you, Emertxe, for giving me this opportunity to work with you, and I look forward to work with you again. Thank you so much. Thank you. This is Veda Shanubogue signing off.